So my pen's working. We're doing the addition rule. And also we were looking at the complements, right? Complements of events, probabilities of complements. Not going to do any more cards. And just do some situations where you have some overlap potentially, two different sets. So here we have 20 college students that are on the boys soccer team. And 12 of these boys soccer team students are in English classes. 6 are in math classes. And 4 are in both types of classes. So let's say we randomly pick a student from those 20. What's the probability that the student is not in math? Not in math. All right, let's do it. Not in math. I'll make it green. So we want the probability of being not math. I don't know, let's draw a Venn diagram. So out here we have our sample space. That's all the boys soccer team players, or students. And here we're going to have English. And here we're going to have math. And we're interested in everyone that's not math. So out here. So math is going to be, I'll make it blue. So we want not math. So everyone outside of math. So the way we often write that, we write this as the probability of bar over math. So that bar is called the complement. It's everything outside of math. All right, so if you use your complement formula, which is handy, you can write this as 1 minus the probability of math. So we're going to write 1 minus, what's the probability of math? Well, how many ways can you get a math student? Here you have 6 different ways, right? There's 6 math students. There's 6 ways to get a math student. 6 divided by a total of 20, right? 20 possible students altogether. Yeah, so the number of students here, the size of your sample space is 20. And there are a number of ways to get a math student. Here was 6. So 1 minus 6 over 20. Let's do 6 over 20. 6 divided by 20, if you do that, is going to be 0.3. Right? 1 minus 0.3 is 0.7. So you have a 70% chance of getting someone who's not taking a math class here. Now, if you didn't want to use the complement rule, what you could have done, you could have said, okay, how many are there in math here? There's 6, right? How many are there outside of math? Well, there must be 14 because they have to add up to a total of 20. So you could have also taken 14 out of 20, those not in math divided by 20, and you'd also get 0.7. That's an even more intuitive way to do it. That's the way I'd probably do it. But you can also use this complement rule, however you want to roll. All right, let's do a number 2. Number 2. What about math or English? Find the probability of getting someone in math or English. I'm going to draw a Venn diagram again. Okay, out here is the sample space. This would consist of all soccer students. Then we got the math. Then we have the English. They're overlapping somewhere in the middle. All right, so we want the probability of math or English. That's talking about all of this here. That's what math or English is. Those two sets combined together in one big set. Well, this is going to be equal to the probability of math plus the probability of English. Let me actually write out the words here. I'm going to write out the words so it's completely unambiguous. Minus the probability of their overlap. What are we going to call the overlap? I'll call it green. Probability of math and English at the same time. Okay, so remember, overall, you have a total of 20 students. It's the size of your sample space. The number of math students, 6. Number of English students are 12. And the number of both math and English. So I should probably use a green color for that, right? That's what we had decided upon, math and English. Math and English. That was, I think, 4. Yeah. Okay, so if I'm finding the probability of getting a math student, it's going to be 6, right, out of 20. And plus, probability of English is going to be what, 12 out of 20. Minus, for probability of math and English, it's going to be 4 out of 20. So I'm going to keep my common denominator here of 20. And on top, I'm going to have, what, 6 plus 12 minus 4. And I do that arithmetic up top. I leave the 20 on bottom. 6 plus 12 is 18. 18 minus 4 is 14. So we got 14 out of 20. 14 divided by 20 is, I believe, 70.7. Okay, well, that's one way to do it. Now, let me show you another way without going through the addition rule. So we use the addition rule. You can do it without the addition rule. So what do we know is in the center? In the center, math and English, we know there are a total of 4 here. Well, there it goes. We don't know how many are out here that are math but not English. We know how many are math altogether, but we don't know how many that are math and not English. Over here, English and not math, we don't know how many are here. So we're going to call X math and not English, and we're going to call Y English and not math. The key thing here is, though, that math altogether is 6, right? So let's focus on the math. Math altogether is 6. So you're going to have X plus 4 tallies up to 6. And to solve that, we just subtract 4 from both sides of this equation. You get X equals 2. So right here, X is 2. That's those that are math but not English. Okay, then you focus on those that are English and not math. English and not math. So I'll focus on English altogether. It's going to be my red. So altogether we have here the English tally up to 12. So when you add those together, you get what? 4 plus y. 4 plus y equals 12. We can subtract 4 from both sides of this equation. You get y equals 8. I'm going to sneak that in there. Y equals 8. So that's English and not math. So remember what we're trying to do here. We're trying to find English or math. So we're trying to, well, wrong color. There it goes. We're trying to find all of this all together here. So all you have to do, you basically add those numbers up. Add those numbers up. 2 plus 4 plus 8, right? 2 plus 4 plus 8, and divide by the total number of students, 20. So when you add those up, you're going to end up getting 14. Oh, wrong color. You're going to end up getting 14 over 20 again, right? Which gives you 0.7. So you can do it that way as well without using the formal addition rule there. All right, let's do one more. Problem 3. Neither math. Oh, well, let me write this correctly. So what's the probability of getting a student in neither math nor English? So if I'm drawing a Venn diagram, this box represents all our student soccer players that are boys. And here are those in math. Here are those in English. And we're interested in them being in neither out here. So not taking math or English. This is neither math nor English. Neither, well, neither math nor English. So what is that? That's the complement of math or English. Oops, wrong color. Right, that's outside of math or English. There we go. That would be the complement of this blue here. So the probability of neither math nor English, that's equal to the probability of the complement of math or English. Right? It's what is outside of math or English. So if we use the complement rule, it's what? 1 minus the probability of math or English. All right, so we got equals 1 minus. So how do we find the probability of math or English? Hey, I think we just did that, didn't we? Yeah, remember? We just found the probability of math or English. What was it? It was 0.7. That was our answer back here. All we're going to do, we're going to plug in here 0.7 from our previous problem. So we got 1 minus 0.7 is 0.3. So probability of having students in neither math nor English is 30%. Okay, so we just kind of bootstrapped off of the last problem. All right, so that's going to be it for our section on the addition rule. So this wasn't completely about the addition rule, right? We also had the complement in there, but kind of the addition rule combined with the complement in these problems.